Hi, in this short video, I want to go over the sequence SAR feature of Datagrok and highlight how easy it is to run such analysis all within your browser. So what we have here is 5,000 sequences of peptides with non-natural amino acids, and also we have the activity column that is going to be used in SAR analysis. Now to run the analysis, you need to go to a top menu Bio, Analyze, and choose SAR. You're going to see a dialog with a web logo on the top, some of the selectors for sequence column, activity column, the histogram for activity distribution, and you also have the option to adjust some of the clustering parameters. So for example, for this data set, I can adjust the parameters like so, select to use web GPU acceleration, and click OK to run the analysis. And immediately I'm gonna see a bunch of viewers that are gonna be added to my original data set, and let's go over them one by one. So on the left side, I'm gonna have the original grid, which is gonna be also split by monomers. So each position is gonna now become a separate column, where again, I can hover over them and see the monomer chemical structure. And on the top side, I'm gonna see the web logo for each of the positions, and hovering over particular monomers are also going to be reacted by some of the other viewers that I have on the dashboard. On the bottom left side, I have the sequence variability map, which shows me the mutation distribution within the data set. So for example, it has two modes, the mutation cliffs and the invariant map, and mutation cliffs is going to show me the number of pairs that differ only at certain position involving only this certain monomer. So for example, the 22 here means that there are 22 sequences that differ only at position 4 and that have the monomer cis-Me involved. So I can click on the 22 here, and on the right side on the context menu, I'm going to see the exact mutations, and it's also going to highlight those mutations for better visualization, and also the individual sequences. I can expand these mutations so that I can see better, and as you can see, the sequence is in the middle and the mutations are highlighted like so. Can also click on individual mutation, and the bottom table is going to react to it and show me the two corresponding sequences. On the bottom, if I scroll on the context panel, I'm going to also see the distribution of activities. So the yellow is going to be corresponding to those 22, and the blue is going to correspond to the overall whole data set. And finally, we also have the selection pane here, which shows the web logo and the individual sequences of everything that I have selected, in this case, these 22. The invariant map is quite similar, but it shows all of the number of all sequences that have this particular monomer at this particular position, and by default, the colors and the sizes are going to correspond to count and the mean difference. So for example, in here, in mutation cliffs, the color is going to correspond to mean difference between the mean activity of the selected sequences versus the overall data set, and the size is going to correspond to count. But through the settings of each of the viewers, you can adjust those, you can adjust the color map, and you can also add some of the other aggregated columns in here. You can also specify the targets for the mutation cliff. So for example, if you only want to target cluster 1 specifically, you can also do that through the target selector here. So if I select cluster and then cluster 1, the viewer is gonna recalculate everything so that its data is coming only from cluster 1, and same goes for the invariant map. Now to the most potent residues. This viewer basically calculates the most potent monomers at each position based on the statistics, and here we basically do the similar thing where you can hover over the cells, see the distribution compared to the whole data set, and basically based on the activities of peptides that have this monomer at this position versus all of the others, we can calculate statistically what's going to be the most potent residue at each position. And same goes here, that you can adjust a bunch of different things through settings like the activity target. So do you want higher activity, lower activity, and so on. On the top side, we have the cluster viewer. So in this case, it's going to be the Markov clustering, which is based on Needleman-Wunsch distance in this case. And based on the clusters that were generated there, so by the way, you can zoom in at any place and see the connections individually, and the viewers are going to be filtered. But based on the clusters generated here, we construct the web logo summary table that is on the right. Here, similar story, we can adjust everything through the settings, and one of the settings is the members ratio, so that the very small clusters are not shown, but in this case, we want them to be shown. And we can see that we have a bunch of different clusters, how many members are in those clusters, the web logo of only this cluster, and the distribution comparison for the activities in those clusters versus everything else. And some of the statistics like mean difference, p-value, and so on. And here, similar story, we can add a bunch of different aggregated columns. So for example, if I choose position 1, it's going to add a pie chart for the aggregation of monomers at position 1. There are a bunch of different options for the analysis itself. They can be adjusted from starting of the analysis, or on the top side, you're going to have this wrench icon, or you can click on it and adjust a bunch of different options like clustering parameters, aggregations, viewers, and so on. And some of the options here, as you can see, are the sequence space. So if you prefer UMAP-based clustering to the Markov clustering, you can choose that. You can also construct a dendrogram or hierarchical clustering on those sequences, and so on. And all of the settings are also quite adjustable, which distances are used, and so on. So let's click OK, and you can see that on the left side, the dendrogram is constructing, and it did. So let's make it, I guess, a bit smaller, and you can see that the sequences are now going to have dendrogram attached to the left side, and you can make the rows much less taller and visualize the dendrogram better. And on the bottom left side, bottom right side, we have the sequence space, which resulted in 4 quite large and I guess less spectacular clusters. But since we also clustered using UMAP, we can go into WebLogo and choose the source of the clusters to be the clusters from sequence space, and it's going to reconstruct everything and highlight and show the web logos for each of the clusters for the sequence space clusters. Again, as I said, there are a bunch of more options that can be played around with in the SAR analysis. Those can be seen at our wiki page. But overall, thank you very much for watching, and see you in the next one.